do to get started. The first is we had a couple of problems from last time that I wanted to make sure that we polished off. So this would be on page 2 of the 1.4 limit laws thing. So we did number 12 on here. Does anybody need one of these sheets, by the way? Yeah, okay, so I've got a couple extras here. Let's see. There's one, two, there's one there, I think. Is that everybody? Or one more? You need two? Okay, well, you guys are going to have to fight to the death because... No, give one to him. And here, take this one. You guys will just have to read the problem solved to me. Okay, so I wanted to look at the rest of these. So let's look at maybe one more. Let me just peek real quick, man, at yours. Let's look at, say, numbers 11. So we looked at 9 and 12, 8, 9, and 12 before. Okay, so let's look at number 11, because there's actually two ways we can do that one. Okay, so what was it? Its limit as x goes to 3 of what? X minus 9 over x minus 3. Okay. Now, important thing to note here is that the minus 3 is not inside the square root. Yeah, did I screw something? Oh, yeah, that makes sense. Because otherwise there's no issue. Okay. Just to make sure it's clear on the notation, the minus 3 is not inside the square root. It's outside. Okay. So sometimes I'll put like a little tail on the end of the square root symbol just to make sure that we're clear on that. Okay, so any brilliant ideas? Well, what was the trick we used last time for something that looked kind of like this? Yeah, not the reciprocal, but what was the word for it? The conjugate, yeah. And then we have to do that the same thing to the numerator as we do to the denominator, because otherwise we're changing the function, right? So what is the conjugate of the denominator in this case? Right, square root of x plus 3. And then if we're going to do that to the the denominator, we better do the exact same thing to the numerator so that we're not actually changing the function. We're just going to change how it looks. Okay, Gucci with that? Okay. Now, we need to multiply things out and maybe try and simplify. Okay, my rule of thumb for this is here we use the conjugate of the denominator, right? So multiply out the denominator. Don't multiply out the other term, just because it'll make your life easier later. Okay, so this is the same as, on top, let me just write it as that. Okay, and on the bottom, let's actually multiply everything out. Okay, and this is again why the conjugate is such a brilliant trick, because what do we get when we do this? Just x minus 9, okay? So whenever you've got the something minus something times something plus something, the middle, the O and the I terms of when you FOIL cancel because one of them has the opposite sign of the other. And so you're just left with the squares of the two individual terms, which is nice. Okay. Well, isn't that perfect? Because what obviously then happens? Yeah, the x minus 9s cancel. And so we're just taking the limit of x plus, sorry, my handwriting's a little messy this morning. X plus 3, or root x plus 3. Okay, so any questions on the simplification step that all make sense? Yeah. Okay. And so now what can we just do? Just plug it in, right? That's the end of it. Okay. So square root of 9 is 3, and so we get 6. Okay. All right. Good. Now let's look at the other two that were sort of fraction city. Yeah. Go ahead. Because that's where the square root was to start with. Okay. So, yeah, so good question. The other problem that we worked at the end last time, the square root thing that we were trying to deal with was in the numerator instead of the denominator. Okay. And so we used the conjugate of the thing where the square root type thing is. Yeah, man. No. Okay, so good question. What is the square root of 9? Is it 3 minus 3, both of them? Okay, so this is actually kind of a technical distinction. So the square root of 9 is just 3. However, what are the solutions to this equation? What are the solutions to x squared equals 9? 3 and minus 3. Okay, so, and actually that reminds me of something I needed to point out to everybody. So why is it that the first one is just 3, but the second one is both plus and minus 3? Okay. The reason is that the square root of x is a function, right? Well, what's true? What are the rules about functions? When you plug something in, what do you get out for any function? How many answers can a function give you? At most one, okay? And it would be 0 if the thing you were plugging in weren't in the domain. So another way to say that is, let's say it were plus and minus 3. If I were to graph that, it would look like this. Well, what's the problem with that as a graph? It's not a function. How do I know that that graph didn't come from a function? Two outputs for a given input. Graphically, what's the way? Do you guys remember from high school? Yeah, the vertical line test, right? If you can if you can draw a vertical line and it intersects the graph at 2 points or more, then the graph that you have did not come from a function, right? And so the square root is only the top half of it, and the other one would be negative the square root, but they're two separate functions. Okay. Um, so yeah, that's the distinction. Now you guys might be saying, well, wait a minute, Dr. McKinney, if I do x squared equals 9 and I square root both sides, right, that would be how you would solve this algebraically. Well, if we just said that the square root of 9 is 3, okay, great. What is the square root of x squared? All right, huh? Who votes it's x? Just x. Yeah? Who votes that it's something else? Okay, what's the something else that you vote for? What's your write-in candidate for this election? Majority thinks it's X. And Eddie, you're not allowed to vote because you should know better. Huh? Yeah. Uh, well, like a lot of other people from Texas, I, you know, will exercise my ability to disenfranchise somebody. So, um, yeah. Um, no? Okay, so if it's not X, what is it? You just don't know. You just know it's not X. Okay. Because if it were just X, I wouldn't be asking this question, right? Okay. It's not just X. It's actually absolute value of X. Okay. And this is why you get two answers, because if the absolute value of X equals 3, then what could X be? 3 or minus 3, right? Okay. Now, how many of you guys think, like, where the hell did that come from? Square root of x squared is absolute x? I've never seen that in my life before. Yeah? Okay. So this is sort of an annoying thing, okay? That anytime you take the square root of something squared, you actually do get the absolute value, okay? And this is something that maybe you saw in high school but promptly forgot, or maybe you never saw it in high school, or maybe you're too busy smoking in the boys' room to notice. No? You guys know that song? Smoking in the boys' room? No? Okay. It's from like the 80s. Uh, um, yeah. Now, what about the cube root of x cubed? That's just x. There's no absolute value. So anytime that the power and the root are even, you have to throw the absolute value in there. And that's super technical and nails you guys every time. Okay. But it is kind of important. Okay. Good? Yeah. All right. So that's the distinction there. Any other questions on that one before we move on? Oui ou non? No? No question? Très bien. Okay. Okay, so let's look at, there were two of them there that had fractions, okay? Now, so just look at the form of the two dudes that have fractions there. Now, clearly we can't just like throw some magic conjugate stuff at it because there's no square roots anymore. Okay, so that trick is off the table. Can you just plug in either of those two situations? No, because let's say that you tried to, what would you get? You get divide by 0, but even worse, what's the numerator in both, both of them, if you plug in? You also get 0. Okay, so these are actually every single one of them in that little chunk of problems, they're all 0 over 0 situations. Every last one of them. Okay. Okay, so we can't plug in, and this clever conjugate trick doesn't work because, well, there's no square roots to conjugate. So what else could we possibly do? Any ideas? Well, we got a whole bunch of fractions, right? How can we like combine things to hopefully then simplify if there's a bunch of fractions involved? Could we do some common denominator kind of action kind of going on? Maybe? Yeah? Okay, so that's what we're going to have to do. So in, let's look at 10 to start with here, 2 over x minus 1. Well, the fact that we've got a fraction there is kind of annoying. Could we rewrite that numerator as a single fraction? Yeah? How would we do it? Uh, well, let's see. You mean when it's all said and done? Yeah, it would just be 1 over x. Okay, now how did you get that? Oh, hold on. No, not just, which one are we on? I'm sorry. Number 10. Yeah. Okay, so can I multiply the 1 there by x over x? Okay. Do we agree that that would be the common denominator of the top piece? Yeah. Okay. So I think what you forgot to do was to do to the numerator what you did to the denominator. Okay. All right. So 2 over x minus x over x, how does that simplify? 2 minus x, whole thing divided by x. Okay. So let me write the problem down and then let's do that. Okay. So it was what? Limit as x goes to 4, 2 of 2 over x minus 1, whole thing over x minus 2. Right? Okay, so what we just said is let's combine the two pieces that are in the top as like so. like that. Okay, so first off, do we agree that I haven't screwed anything up here? No. Good? Okay, muy bien. Okay, now we need to do the simplification. Does it look like anything cancels right now? But it's not as obvious as it was before. Okay. So what cancels here? 2 minus x and x minus 2 are negatives of each other, right? So let me rewrite this one more time to make it a little bit more obvious. Do you guys agree that that's the same thing? Right? 2 minus x is negative x minus 2. We? Okay. Now, let me also then, because when you've got fractions on top of fractions, sometimes it's easy to make an error. And so let me rewrite it like this. Okay, so you see how I'm trying to make the sort of main division a really long division bar there? Because if I make all the division bars the same size, then what's sort of the problem? It's not obvious who's on top of whom, right? So either make your division bars bigger and some smaller in order to suss that out, or do what I did in the second step, which is rewrite it as a product of fractions, and then it's easier to see. Okay. All right. So is that cool? All right. And now what happens? The x minus 2's cancel, right? Yes. They all cancel. Okay. This is one reason I hate teaching 8 a.m. classes, because you guys are dead. And so we're just taking the limit of negative 1 over x, right? Can I just plug in now? And what do I get? Yep, negative a half. All right, Julius, you got the suspect look on your face there. Because of the minus sign, yeah. And so obviously if you are in a hurry and you forget that minus sign, then you'd get a half instead of minus a half, which is wrong, right? Okay, good. All right, so let's take a minute. Any other questions on this one, this sort of common denominator kind of thing? It's a little messy because it's fraction foo, but, you know, these are big boys. So why don't you look at next and take a minute or two to try the other one that's on there that's got the fraction. And what was that one? Can you read it off to me? Limit as x goes to 1 over x plus 4. Okay, all over. That's it. And then what was x approaching? 0. Okay. Yeah. Okay. All right. So take a minute and try that one, and then we'll compare and see what you guys get. Where's our boy? Well, let's send him a angry text message and say, dude, where you at? to get the cups back out. I don't know, something tells me there might be a little bit of red solo cup action happening this weekend. What do you guys think? Yeah. Any crazy parties going on this weekend or no? How many of you guys are still salty about the fact that we haven't canceled a single class? Yeah, you're salty about this? Yeah, well, you picked the wrong college to go to. Huh? Well, okay. I did because I was, puking my guts up, but uh, for snow, pff. In fact, the last time that the college canceled classes, uh, period, um, I guess I can say it on Twitch because it's not like it's not public knowledge. Uh, there was an employee of the college who went on a murderous rampage, then came to the college, checked out a college vehicle, and then fled to Indy and holed up in a hotel room. And eventually, when the cops finally figured out where he was and, basically told him, come out with your hands up, he shot himself. Yeah. Oh, there was also a tornado, but that only canceled a single class because it was on a Wednesday evening, and there's only one class that meets in the evenings, and it's on Wednesdays, and it's only for seniors, and it's only for 15 seniors. So, yeah. Last time classes, plural, were canceled was the murderous rampage. And before that, I think it was 9/11. So, and before that, I think there was a blizzard in like 1973. And then before that was when JFK was assassinated, right? So it basically takes terrorist attacks, murderous rampages, presidential assassinations, right? Uh, that's what it takes around here.
How long ago was the murderous rampage?
6 or 7 years ago. Yeah, sorry. Yeah, the rampage, the murderous rampage thing was really sad because basically it had nothing to do with the college. It was, you know, a family fight between relatives over money or inheritance or something, and he, killed his niece and her 4-year-old son. And yeah, it's absolutely terrible, the whole thing. But yeah, money will make people do strange things. So okay, so let's look at this. Do you guys agree that this would be the first step? Okay, so what have I got highlighted in green and blue? I've got the two terms that I need to multiply by in order to get a common denominator. So this one's a little spicier than the last one, right? Because I have to multiply both terms by something in order to get a common denominator. So what's the common denominator here? 4 times x plus 4. Okay, so the first dude is missing the 4, and the second dude is missing the x plus 4. Okay, all right, so we agree with that. All right, so now let's start simplifying a little bit. So I'm going to get 4 over x plus 4 times 4 minus, okay, and we got to be careful with the sign here, x plus 4 over 4 times x plus 4. All over x, and then I've got the limit out front. Okay, so you'll notice that I didn't multiply out the denominator here. I could have, certainly, but I'm going to refrain from doing so. I could always do it later if it seems like a good idea. Okay. So what should I do next? Yeah, let's combine the two fractions that are in the top, okay? And let's be careful with the signs because when I do that, what happens? It changes sign, but the fours cancel. So I get on top, I just get this. And on the bottom, I just have x. Okay, so do you guys agree with that simplification? We? No. Okay, so now, like before, can we cancel the x? Okay, and so we get -1 over 4 times x plus 4. Okay, um, and then once we've canceled the x's, can we just plug in x equals 0? Yeah, totally. And so what do we end up getting in when all's said and done? -1 over 16, exactly. Okay, because it's 4 times 4, basically. Yeah. Okay. Good. All right. So for now, these are kind of the three tricks that we have at our disposal. Okay. Um, we've got the conjugate trick, fraction foo, and clever factoring. Okay. And there are more tricks. For example, those of you guys who go on to Calc 2, or actually some of you may have seen this before, who took some calculus in high school. Did you ever hear about L'Hopital's rule? Yeah, do you remember L'Hopital's rule? No, a little bit. Okay, so that's another trick. Okay, for those of you, we teach it in Calc 2 instead of in Calc 1. I mean, it doesn't really matter. It's just got to go somewhere. So those of you guys go into Calc 2, that'll be one of the early things that you learn is L'Hopital's rule. And if you happen to know it, I mean, it's fair game unless I explicitly tell you otherwise. Um, yeah. So anyway, okay, good. We all right. So on the subject of some limits, let's look at the very. We did the squeeze theorem stuff last time. So let me steal this for just 1 second. Let's flip over to the very back page, which has some special limits. And these are ones that we just kind of have to memorize, which sucks, but c'est la vie, okay? So the first one was limit as x goes to 0 of sine of x over x. Yeah? Okay. And this limit is 1. Now, you might think that this is coming out of thin air. And what would be maybe a way that we could guess that 1 is about the right answer? Like, what can we do to maybe suss it out a little bit? Yeah. For very small x's. Okay. So if we measure x in radians, which we do in calculus because that works better than degrees for technical reasons, for extremely small angles, the sine of x is actually approximately equal to x. Okay. And well, then x over x is 1, right? So this should be approximately equal to 1. And how do we know that we have sort of tiny angles? Well, if x is approaching 0, that's sort of the definition of small angles, right? Okay, so that's true. Now, how many of you guys actually knew that approximation for sine? Uh, has anybody taken astronomy before? Now, sometimes you actually use that approximation in astronomy. It's sort of good enough for government work. Okay, well, if we didn't know that, what's another way to maybe approach this to see as to why this might be true? Bueller, Bueller, Bueller. This is where one of you have to say he's not here today. You guys not seen Ferris Bueller's Day Off? Oh, Lord child, you have work to do this weekend. That's your homework. One of your homework assignments is to watch Ferris Bueller this weekend on like Netflix or something. I don't know. Huh? It's probably on Netflix or Amazon or Hulu or any of the other, you know, 15 million streaming services that there are now. Disney Plus. No? Okay. Um, so could we graph it and maybe suss out what might be going on? That'd be a good idea? Yeah, let's try that. All right. So how are we going to graph things? Oh, if only we had a website that makes it real easy to graph stuff. Wouldn't that be great? We could call it Desmos and we could make millions. Okay. All right, so here's the graph of sine x over x. Now, does it make sense why it's basically zero for large values of x? Well, what do we know about sine of x? It's between -1 and 1, right? And what happens if you divide by really big numbers? You get really small numbers. So that's why this thing basically goes to zero out away from zero. But near zero, I don't know, 1 seems like a pretty convincing answer to me. Yeah? And it turns out that is what it is. Okay? It is possible to prove this, but it takes a little work and yeah. Okay, so great. Now on the subject, let me go back to the other the sheet, and then we'll do. Okay, what were the other ones on there? Uh, limit as. So what was the second one on the list there? Uh huh. Yeah, this equals 0. Okay, this one's sort of similar. Cosine instead of sine, whatever. Um, we could graph that one and kind of establish it for the same reason. Um, and then what were the other ones? Limit as x of. Oh, to the, yeah, here, let me just see it real quick. Yes, 1 over x. Yeah, okay. Um, and actually, I can rewrite that a little bit. I can also say it this way. This is equivalent. Okay, and when I write E here, what number do I mean? Yeah, so E, 2.718, blah, blah, blah. It's the base of the natural logarithm, that thing. Yeah, okay. So this one is actually kind of interesting because I can give you another sort of demonstration as to why this is true, um, other than graphing it or something. Okay, so does it? I rewrote it like this. Does this kind of form remind anybody of something from high school, maybe that involves money? You guys remember the compound interest formula? No? Okay, well, that's all right. I'll write it down. All right, so let's say that you borrow money. Let's say that you borrow A naught dollars. You borrow them at a interest rate R. The principal is compounded n times per unit t. And then you want to know how much do you owe after t units of time. Okay, so for example, let's say that you want to buy a car, right, and that you uh, need to finance most of it, right? That's usually how that works. Okay, so What kind of car would you guys buy if you had carte blanche to buy anything you wanted? Oh, come on. Nobody has a dream car? None of you? Okay, fine. You guys are worthless. So let's say that you want to buy a car, okay, and you put some money down, and maybe you need to finance, say, $10,000. Okay, I'm just picking a number here. Well, let's say that, and this isn't a perfect model for this, because let's say that you borrow this money and you don't start making payments. Okay, now what normally will happen if you do that? Well, the car's going to get repoed, right? But let's pretend that that's not going to happen, right? So you borrow $10,000, and let's say that you don't have to start paying for 5 years or something. Well, after 5 years, how much are you going to owe on that car if you pay nothing on it as for those 5 years? Is it going to be more than $10,000? Yeah, because of interest, right? Okay, so let's suppose that I am the world's most evil banker, okay? And I'm going to loan you $1, but I'm going to loan you $1 at 100% daily interest. Okay, that's pretty expensive money, right? Okay, so let's suppose that I loan you this dollar. How much do you owe me at the instant that I've loaned you the dollar? $1, right? How much do you owe me one day later? $2. Now, how'd you get that? The $1 of principal and $1 of interest, correct? Okay. Now, that's assuming, though, that I compound that interest daily. What about if I compound it hourly? Okay, so I compound it 24 times over the course of the day. Would you owe me $2 or more than $2 after the end of the day? More than $2. Now, how many of you guys think it'd be like $3? How many think it's somewhere between $2 and $3? What do you get? What would you guess? It's more than two. Any guesses as to what the number is? Well, let's compute it. All right. So I just need to use this formula, and I'll use Wolfram Alpha for this because I like it. Okay, so I need to compute $1 times 1 plus 1 is my interest rate divided by 12, or sorry, 24, because there's 24 hours in a day, to the power of 24 times 1, because it's one day and I'm compounding it 24 times. All right, you would owe me $2.66. Okay, good. All right, that's compounding hourly. What about if I compounded this every minute? What do I need to do with my 24s? Multiply them by 60. Okay, so let me do that. Well, but like this with parentheses, right? Because yeah. So to the power of, what did I say? 24 times 60. Okay. Now, that's compounding every minute of the day. Could I compound every second of the day? Right. And do you notice that that number, it's going up, but is it going off to infinity like maybe you expected it would? No, it's going off to, does anybody, yeah, 2.71? Anything seem familiar there? Huh? Well, let's throw in here. Let me throw in a times another 60. Um, Dang it. sorry, the thing got in the way here, times another 60 times another 60. 2.7182, blah, blah, blah. Does that number look familiar? That's E. Okay. Now, this makes sense because what was the other interest formula that you guys learned in high school? The PERT formula? PERT is continuous compounding. That's what happens when you let the number of compoundings go to infinity, right? And so this formula reduces to the PERT formula in the continuous situation. Oh, that's kind of cool. Yeah. So, yeah. Wow. So never borrow money from McKinney, I guess, is the moral of the story. So, okay. So we should probably quit. And I've got some things to hand back to you and a couple of just quick pieces of business. So, video problem, you guys all saw the actual what the problem is. Yeah. Okay. Now, if you've got an iPad where you can do drawing and recording, you're fine to use that. You want to use your phone and find a whiteboard or a blackboard somewhere and be like, hey, TikTok fans, I'm going to do some calculus, right? Whatever. You can upload the file to Canvas, or if you want to post it to YouTube, even if it's a private link, so that you just give me the link or whatever. Okay. It doesn't matter to me. Just as long as I can see what the hell you're doing, we're all good. Okay. And if there's any technical problems or whatever, just ask me. Okay, what are we doing on Monday? Yeah, your next assessment. Okay, and in particular, what's going to be on it? Okay, what's going to be on it is stuff up through say the one-sided limits, which we did on well, I guess what, Friday last week, right? Not the stuff that we did Wednesday and today. Okay, that'll first appear on the next one. Yes. Up to and including it. Yeah, yeah, yeah. Um, and along with anything that you didn't pass from before, which I have bad news for you guys, was everything for all of you. You all suck. Okay. The your algebra, you guys need to brush up on some stuff because you all flubbed at least one of the problems. So I was a sad panda in that sense. Um, okay, so anyway, I think that's it on the business end of stuff. So I'll hand these back and you guys have a good day.